This is homework video for Algebra 2, MidChapter Review, Chapter 8. Chapter 8 is rationals, and rationals are fractions, algebra fractions. And in 8.1, we did times and divided by rational expressions. So a basic review, when we multiply fractions, this is true. So this is a basic review with numbers, and we're doing this with algebra expressions, polynomial expressions specifically. But when we multiply fractions, we multiply straight across. When we divide fractions, that is to multiply times the reciprocal. I flipped the second. Reducing, I'm not sure how much reducing we're doing here with our fractions, but in any case, we do need to. Okay, 8.2, we are plussing and minusing. And what is true for plus and minus both, you have to have the same denominator. So we would rewrite this to be base 15, do the same to the top. So if here I'm multiplying times 5, I need to multiply this times 5, making that 10, multiply this times 3 to make 15, same denominator, and then 4 times 3 is 12, and then I can add, and I get 22 over 15. So we're applying that principle here with our rational adding and subtracting. We've also done 8.6, solving. And I was going to do that here as a review. It's not actually included in our mid-chapter review. Our mid-chapter review is going to cover lessons 1, 2, and 3, but I think I'll just save this until end of chapter review, so not for now. And 8.3 we did earlier this week, and that is graphing reciprocal functions. So reciprocal functions are a type of rational function. Parent equation 1 over x, and the graph looks like so. We'll get into that specifically in our lesson. So that's a quick snapshot. We're going to do so the actual book's review is covering 8.1, 8.2, and 8.3. So let's get started. Page 552. All right, page 552. We're going to do 1, 2, 5, and 8 on this top section of simplifying. 1, 2, 5, and 8. Problem 1. All right, so here we're dividing by a fraction, which means we multiply by the reciprocal. Oh, darn, I am not on the right page at all. I think that was right. Here we go. Page 552. We're going to do 1, 2, and 5. I don't know how to pause this and rewrite it, but anyway, sorry about that. Okay, page 552. I was on the practice test by accident somehow. All right, so right now we're going to do 1, 2, and 5. So number 1 is multiplying. And because this is multiplying and everything up here is multiplication, this is all multiplication. There's no plus or minus anywhere in this fraction at all. So it is actually, if I knew how to squish this together, I'm not going to rewrite it. This is actually all on the same. This is all the numerator. It's all multiplication. This is all multiplication down here. So I can go straight into canceling. And let's cancel top to bottom and write the result to the side. So the 2 and the 18 cancel, leaving a 9 at the bottom. The 7 and the 14 cancel, leaving a 2 at the top. At the top, I have 3 x's. At the bottom, I have 7. Oh, so that's going to cancel against this, leaving x4 at the bottom. All right, y's. I have 6 y's at the top and 2 y's at the bottom. That's going to leave 4 y's at the top. And lastly, I have 2 z's at the top, 1 z at the bottom. That's going to leave 1 z at the top. Okay. And check my answer. That is correct. Number 2. Number 2 is dividing. So remember, when we divide is to multiply by the reciprocal. So I'm going to write it directly as the reciprocal. So our first part, 24, a to the 4th, b to the 6th over. So I'm going to rewrite this as multiplying by the reciprocal and flip it directly. So on top goes 7a2c. On bottom goes 12 ABC. Again, I don't have any plus or minus symbols. This is all multiplication, so I can go straight into canceling. All right, 24 divided by 12 is going to leave a 2 on top. 35 and 7 both divide by 7, leaving a 5 on the bottom. Let's see, we have 6 A's on top. We have 2 A's on bottom. That leaves 4 A's on top. I have 6 B's on top and 4 B's on bottom. And my C's cancel out completely. Let's check our answer, 2a4b2 over 5. Okay, number 5. 5, look at this craziness. So I have a fraction divided by a fraction. I'm going to go straight to rewriting this, but I'm looking at your page. You should be also. So you have a fraction. The numerator is a fraction, and the denominator is a fraction. So that means I have a fraction divided by a fraction, and dividing by a fraction is to multiply by its reciprocal. So I'm going to write it accordingly. So I'm going to write the top fraction. And this is going to be times the reciprocal of the bottom fraction. So that means 3r plus 3 goes on top, and 3r goes on bottom. All right, here I do have pluses and minuses, so I can't just start canceling because this is in fact a separate term. But what do I have now? I have 2 binomials that I need to FOIL. So we have this binomial times this binomial, and so I need to FOIL it. So r squared times 3r is, oh, I want my cursor to show up. I wonder if I could make that happen right now. I'm using a different screen recorder and I haven't fully figured out how to use it. So I wish that my cursor showed up. I noticed in the last video that it did not. All right, well, anyway, r squared times 3r is 3r cubed. Outer, r squared times 3. I'm just doing FOIL on this top. And then here I have a binomial times a monomial. You're going to distribute the 3r by multiplication to each term. And we have all right, we're going to now combine like terms. So right here, this combining like terms, this becomes 12r squared. And if you look, so now we have 3r cubed plus 12r squared plus 9r. And for our second line, we're going to now factor out the greatest common factor, which is 3r. And so that means you divide each term by the greatest common factor, and then what's left is written in here. So 3r cubed, I really want a visible cursor. 3r cubed divided by 3r is going to be r squared. 12r squared divided by 3r is going to leave 4r. And then 9r divided by 3r is going to leave 3. All right, in my numerator, I'm going to factor out a 3r in the denominator, like so. And notice this can be factored. And this is r plus 1, r plus 3. So now I can cancel. So my 3r's cancel, the r plus 1 cancels, and the only thing that's left is this. My answer is r plus 3. Isn't that so satisfying when it all cancels? All right, moving right along. Next, we're going to solve 8. Next, we're going to solve 8 and 9. All right, so 8. Identify all values of x for which this rational function is undefined, which means what can x not equal in the denominator that causes it to be 0? That's all that means. Undefined. What cannot be true in this equation? So we need to factor this denominator, which is going to become x minus 9, x plus 3. The x plus 1 is already there. So x cannot equal 9, x cannot equal negative 3, x cannot equal negative 1. Because when x is 9, this becomes 0, and you can't have a 0 in the denominator. If this becomes 0, then that causes the whole denominator to be 0. And you can't have division by 0. So for these values of x, this expression is undefined. The answer is H. All right, number 9. What is the lowest common multiple of x squared minus x and 3 minus 3x? So let's factor these guys to find out. So x times x minus 1, 3 times 1 minus x. So these are almost the same, but they're not quite the same. What if I apply a -1 to each piece of this and rewrite this as -3 times -1 plus x, and then rewrite this x minus 1. Now I have a common factor by flipping the sign, and this still holds true to my original. So there's no magic happening here. It's just applying math rules that are still true. If I multiply this back, I get a -3x. That's true. If I multiply this back, I get a +3. That's true. So this factor set is x times x minus 1. This is -3 times x minus 1. X minus 1 is in common. I need to multiply this, the x and the -3, to make a lowest common multiple. So the answer is -3x times x minus 1. All right, next we're going to solve let's see, 10, 12, and 14 for this next section. All right, so we're simplifying expressions, and we have, for number 10, we have a fraction added to a fraction. I'm going to stack this vertically, because then when I change my denominator, I find it a little cleaner to rewrite with same denominator. So I'm adding fractions. I must have I really want a visible cursor, guys. Why can't I have visible cursor? I need this denominator to equal this denominator. So coming out here to the side, what needs to be true? The 4 and the 3 are going to multiply to be 12. Right now I'm working on my lowest common multiple to rewrite with the same denominator. You take the highest exponent value of variables, so x2 and x2. x2 is going to be my lowest common multiple. And then I have y and y3. y3 is a part of my common denominator. So the lowest common multiple is going to be my common denominator. Now, whatever I do to the bottom, I must do to the top. That's my general fraction rule for adding and subtracting fractions. So how do I get from 3x y3 to 12x2 y3? So this is going to be times 4 times x, and the y is already good. So I must multiply the top by the same. Going back to the top, what did I do here to turn this into this? So it's times 3. The x is good, and I need a y2. So I need to multiply the top by the same. So this is multiplication symbols. So my bottom is done already. We did that first, right? So now we need to multiply the top. We have 2x being multiplied times 3y squared. 2 times 3 is 6. The x stays the same, and y2. And now I need to do 4x times x, which is going to be 4x squared. This is plus. So this becomes 6xy squared plus 4x squared over common denominator 12x squared y3. Let's double check the answer, and that is correct. All right, 10 is done. We're now going to do number 12. All right, here we're subtracting fractions. Again, I'm going to stack it vertically. I'm going to hug the side. 6 over r squared minus 3r minus 18 minus fraction 1 over r squared plus r minus 6. So in order to proceed, we first need to factor. We need to factor first to see what we're dealing with. So the 6 is factored and the 1 is factored. We need to factor our denominator, and that's going to be r plus 3, r minus 6, r plus 3, r minus 2. We need a common denominator, so we have r plus 3, r minus 6 in the top. The r plus 3 is common, so I need to multiply this times r minus 2, same on top and bottom. And then down here, I need to multiply top and bottom by r minus 6. So I will now have a common denominator like so. And the bottom, this is going to this numerator. So that's going to be r minus 6. Up here, multiplying, this is multiplication. This is 6 times r minus 2. I'm going to distribute the 6, and I get 6r minus 12. Now, notice what happens next. So I now have two fractions with the same denominator. I need let's see. I know what I can do. Hopefully this doesn't. Let's change to a highlighter. So I now have this, that works. I now have the same denominator. So now I can do the math. And remember that I am subtracting these two fractions. So this is going to become 6r minus 12 minus, again, that's coming from here, minus r minus 6 over my same denominator. So this becomes 6r minus 12 minus r plus 6. When I flip the signs, basically there's an invisible 1 right here. So it's -1 times r, -1 times -6. That becomes this. Combine like terms for my final answer. And my final answer is 5r. 6r minus r is 5r. -12 plus 6 is going to be -6. And that is a correct answer. All right, 12 is done, and I am to do, where's my little list? I lost it. Oh, 10, 12, we have 14 to go for this section. All right, 14, I am adding, so this is just additional practice. X minus 4 over, this is being added to factor first. See what we're working with. X minus 4, x plus 1. This is already factored, no change on the top. All right, and here I need to multiply by 2 in order to have a common denominator. And down here, what's missing? I need to multiply by x plus 1. My common denominator is now going to be 2 times x minus 4, x plus 1. And on top, we have a binomial times a binomial. Foiling that becomes x squared plus 2x plus 1. And then on the top up here, I have x minus 4 times 2. Distribute the 2. And when we put all this together, because we have the same denominator now we can do the math, and the math is to add the fractions. So I am going to 2x minus 8 plus x squared plus 2x plus 1 all over the same denominator of 2 times x minus 4, x plus 1. Combine like terms for a final answer of, I'm going to write my common denominator first. And now I'm going to combine like terms and put them in descending order of the variable exponents. So we're going to have x squared first. I'm going to cross that as I go. I have 2x plus 2x makes 4x. Minus 8 plus 1 is minus 7. And that is the correct answer. Okay, so our next section, 15. 15, determine the perimeter of the rectangle. So remember that perimeter is the distance around, and that formula is 2 times length plus 2 times width. And we have a length of, so for this that means 2 times 6 over x minus 3 plus 2 times 3 over x plus 1. And we do the math. And we need to have common denominators in order to do the math. I like to stack it instead. This needs to be multiplied times x plus 1. This needs to be multiplied times x minus 3. My denominators are now the same. 6 times x minus 3, distribution, 6x minus 18, 12x plus 12. This is addition. Because my denominators are the same, I can now add the numerators. And that becomes 12x plus 12 plus 6x minus 18. Combine like terms, 12x plus 6x is 18x. And then 12 minus 18 is minus 6. All right, so that is the perimeter of the rectangle. All right, next we're going to be working 17 and 18. Okay, so now we're on to lesson 8.3 review. And this is our reciprocal functions. So here we're looking at the graph, and if you can grab your ruler to help you see. But here we're identifying asymptotes, domain, and range, and these are kind of fun and easy after working in 8.4, aren't they? So I can see by looking at the graph that my my horizontal asymptote is at y equals 0, and that determines my range restriction, which is that y cannot be equal to 0. I can see that my vertical asymptote is going to be at x equals -3, and that determines my domain restriction, which is that x cannot be equal to -3. And number 18, similarly looking at the graph, we have a horizontal asymptote at y equals 4. A vertical asymptote at x equals 6. All right, now we're going to, okay, so we're moving into the last section. We are going to do 19 through 24. We're going to do the odds by full graphing. I am not able to, at least I don't yet know how to add a Cartesian graph to here. Let me change my background to there. That's the best that I know how to do right now. Okay, so, but I want you to use your graph sticky notes. Ideally, I gave everyone a new pack recently, or if not, then you need to draw lines and number them. So for these graphs, for 19, 21, and 23, you need to have specific graphs. So, and we're going to do our own XY table. Let's do a quick review first. This is rational functions. These are rational functions, but it's a specific type of rational function that is a reciprocal. The parent function is y is equal to 1 over x, and this equation, the full equation, is that y is equal to 1 over x minus h plus k. If there's a negative, that reflects it, flips the graph, turning it into this. The main graph for here is like so. And so the h value is going to be, it's going to translate it left or right, and this determines our vertical asymptote. And then the k value is going to translate it up and down, and this determines our horizontal asymptote. So let's start with number, how we doing? Oh, not too bad. My time. Okay, so 19 is y is equal to 4x, and we'll do an xy chart for this. All right, right off the bat, we can say that our horizontal asymptote, there's no h or k value, so that means that both are going to be at 0. And we know what those domain and range restrictions are. All right, so when x is 1, that's 4 divided by 1, that leaves 4. When x is 2, that becomes 4 divided by 2, which is 2. When x is 4, 4 divided by 4 is 1. -1. All right, and again, for these guys, I want us doing specific graphs. Asymptotes. Equals 0. And my graph points, 1, 1, 2, 3, 4. I'm looking for the points of my curve, 2 and 2, 4 and 1. And now I can draw in that curve. And then at the bottom, -1, -4, -2, -2, -4, -1. Beautiful. All right, 21. One's equation is that y equals 6 over x minus 1. My h value is 1. So that means that my vertical asymptote is at x equals 1. I do not have a k value, so my horizontal asymptote is still at y equals 0. We are going to do an actual xy table. And so when x is equal to 2, that's 6 over 2 minus 1, 6 turning into 6 divided by 1, which is 6. When x is 3, I want you doing this math, please. We're plugging in values of x into here and then doing the math to find out what y is. All right, again, specific graph. You don't need Desmos for this. You need to be able to do what's happening here for the test. Okay, draw in our asymptotes. We have a vertical asymptote at x equals 1. A horizontal asymptote at y equals 0. And we have points at 2, 6, 3, 3, 7, 1, 6, 7. So there's our curve for this one. Beautiful. All right, last one we're going to fully graph is 23. Getting some more transformations going. All right, this is our horizontal asymptote. Y equals 5. This is our vertical asymptote. X equals -2. And we're going to do an XY chart. Plug in values of X. Oh, so, to be able to determine some smart X values, graph your asymptotes first. So X equals -2. And y equals -5. So this is my x, this is my y. All right. Y is -5. 1, 2, 3, 4, 5. So my graph is going to be, I really need to be, oh, wait, highlighter. Okay. So it's positive, it's not reflected. So my graph is going to be, I have a dilation of 3. My graph's going to be somewhere like this and like so. So use that to estimate some smart x values when you're doing yours. So to get the points in here, that would be an x value of -1. I mean, sorry, wait a second. Yes, we should have a -1. Okay. When x is -1, plugging that into our equation, that turns into -2. Because that becomes 1, so 3 minus 5 is -2. Okay, so another good point is, so that's here. And we can go ahead and put that in here. -1, -2. Good guesstimate. All right, we can enter 0. What happens when x is 0? Well, that makes it harder. I don't want to do that one. I don't want to deal with fractions when I don't have to. When x is 1, 1, 2, 3, 4. And what else can we do? I think that's good for that point. And look, works out nicely. All right, and then some other values to get over into this range. When x is -3, what do we have to get us down into this range? So I need a cursor that works, guys. Next video, I'll figure it out. Okay, when x is -3, plug that in, and out pops -8. 1, 2, 3, down 8. 1, 2, 3, 4, 5, 6, 7, 8. Not too bad. And -5. So going in this range, what happens when we have x at -5? We get -6. 1, 2, 4, 5, down 6. 4, 5, 6. So now we have 2 points, and we can sketch in our graph. Okay, that's the last one that we're going to graph fully. On your page, on your homework page, I want to see you doing specific lines again, not just estimates. Hopefully sticky note graphs. I just can't do it on my screen. Okay, we're going to do 3 more problems. We're going to do the evens, and we're simply going to apply our excellent, amazing understanding of transformations as we do so. So equation 20, we have y equal to 1 over 3x. So in this case, I'm just doing quick mini graphs. I don't have an h or a k, which tells me that my asymptotes are at 0 again. And this is positive, not negative, so it's not flipped. The 3 is going to make this tight. So my graph is tight. This is what my graph's going to look like. Here you can go into Desmos to help you, but I really do want you to do these last 3 where we're thinking a bit about what our transformations do. Okay, now we have a negative. We have a -2 divided by x plus 4. The 4 is going to cause this is my horizontal asymptote, it's going to be 4. The whole thing is going to shift up. It's going to translate up 4. The 2 is going to dilate it. The negative is going to reflect it, flip it. I do not have an h value, so that means that I'm going to be at x equals 0. Quick graph, quick asymptotes. Just estimate this. It's flipped. That means that I'm going to have a graph in these quadrants, this portion of your asymptote. All right, last problem, 24. This guy's got all the transformations going on. All right, we have a minus 1 over x minus 3 plus 2. The 2 is going to translate the entire graph up 2 at y equals 2. The 3, all right, watch what's happening here. So if you ignore the negative, then this would be a translation right 3. But check out our negative. We have a negative times a negative, which makes a positive. So this is going to turn into a vertical asymptote. Negative, negative, positive. It's going to make it go left 3. And the negative, again, is going to flip our graph. Quick sketch. We have a vertical asymptote at x equals negative 3. So I'm not actually using just quick mini graphs here. And then I have y equals 2. And this is flipped. So my graph is going to be like so. All right, that is it. I feel reviewed. I hope you do too. See you in class tomorrow.